Hey guys, happy Thursday. So today we are going to combine everything that we've learned about number patterns, data boxes, relationships, and graphing on a coordinate grid. And then you have spring break after this. So woohoo. All right, so here we go. A bakery can fit either 6 regular muffins or 4 jumbo muffins in each box. Each box will contain either all regular or jumbo muffins. Complete the table to show how many of each muffin will fit in 2, 3, or 4 boxes. And then it asks us to generate ordered pairs and graph them. So the rule for regular muffins is 6, okay? So if you have 2, you're adding 6 here for regular muffins. Sure, my videos are incredible. All right, so for 2 boxes, it's adding 6, so 6 plus 6 is 12. And then for 3 boxes, 12 plus 6 is 18, or remember, like we learned yesterday, 6 times 3 is 18. For 4 boxes, 18 plus 6, or 6 times 4, is 24. If you have the jumbo muffins, they can only fit 4 to 1 box. So for 2 boxes, you would be able to fit 8 muffins. For 3 boxes, 8 plus 4, since the rule is plus 4, or 3 boxes times 4 jumbo muffins is 12. And 4 boxes would be 16 jumbo muffins. So this would be our data chart for the muffins that the bakery can fit into each box. But we're not done. It wants us to complete the table, which we did, and then generate ordered pairs. So I think I put a text box out here. Yes. Okay. So your ordered pairs you have to determine first which is an X and which is Y. So I would always say that the top box is X. So that's the first one. That's what's going to come first. So for 1 box, your ordered pair is 6, 4, because there are 6 regular muffins and 4 jumbo muffins. 2 boxes will be 12, 8. 3 boxes would be 18, 12. And then 4 boxes would be 24, 16. So in order to graph this, drawing is going to be beautiful, I'm sure. I'm going to draw my coordinate grid. The bottom is going to be the regular muffins, reg, and the side is going to be jumbo, jumbo. All right, and I am going to have 1, 2, 3, 4. We need to go all the way up to 24. It's going to be a long video if I do that. So all the way up to 24. Wow, honey. It's a cough drop. For jumbo, we need to go all the way up to 16. So we would have 1, 2, 3, yada, yada. Let's not make it a long video. All the way up to 16. All right. So my first ordered pair is 6, 4. So I'm going to go over to where 6 would be and up to where 4 would be. I'm going to do my little dot. Then I've got 12, 8, so over to 12, up to 8, then 18, 12, so over to 18, up 12. So you can see the line's going to look kind of like this. And then the last one, over to 24, up to 16. And then you would connect your dots in that beautiful line that I have. So now we have completed the table and we have generated our order pairs here and then graphed them. Next, let's look at another example. All right, so here's another example. Well, Jill is earning $5 per hour babysitting and Robin is earning $15 per hour teaching ice skating lessons. So they made a table and Jill's rule is add 5 and Robin's rule is add 15. So they want us to complete the table, compare their earnings, and then graph the ordered pairs of the corresponding terms. So as you can see here, a lot of Jill's and Robin's chart is already filled out. Let's kind of check what they did. At 0 hours worked, they earned 0 money. At 1 hour work, Jill earned 5, Robin earned 15. Jill's is add 5, so hour 2 is 10. Robin's is add 15, so 2 hours is 30. So if we continue this rule or these rules to figure out how much they earned in 4 weeks, Jill's was again add 5, so 15 plus 5 is 20. And Robin's is add 15, and 45 plus 15 is 60. So we know how much they earned in the 4th week. So if you compare the number in Jill and Robin's sequences, each sequence, so it begins with 0, right? And each term in Robin's pattern is 3 times as great as the corresponding term in Jill's pattern. So what that is saying is, remember when we looked back and we said, okay, look at week 1 with the smallest numbers, okay? How many times bigger or smaller is one than the other? Well, we have determined that Robin is always earning 3 times more than what Jill is earning. And then we're going to check it with another week down the row. And let's check it with week 4. Is 20 times 3 60? And the answer is yes. So the relationship here, the relationship is that Robin is always earning 3 times more than Jill. Now to generate ordered pairs, we're going to say that Jill is X and Robin is Y, and we're going to put it into this data graph here. So nothing has changed between this data graph up here and this data graph down here. It's just one is side to side, horizontal, and one is up and down, vertical. And then they have graphed right here. So 0, 0 is at the origin. The next pair is 5, 15. So over 5, up 15, there's that dot. Then there's 10, 30. So over 10, up 30, there's that dot. Then 15, 45, over 15, up 45, there's that dot. And then 20, 60, over 20, up 60, there's that dot. And here are those ordered pairs that they asked us to create. So data chart, ordered pairs, coordinate grid. All right, now the classwork is dealing with this problem as well, but I'm gonna have to kind of switch back and forth. So it says, on this example, what ordered pair would you write for how much Jill and Robin have each earned after 5 hours? So let's go back over here. We said that at 4, it was 20 and 6. We also know that because Jill's rule is plus 5. So 5 times 4 is 20. So 5 times 5, the 5th week, would be 25, right? And then we're adding 15 to Robin's. So 60 plus 15 is 75. So let's remember that, 25 and 75. And let's go back over to the classwork here. So Jill is, did I say 25? And Robin is 75. Okay. So Ben says that the relationship is that Jill earns 1/3 as much as Robin. Do you agree? Well, we said that Robin always earns 3 times more than Jill. So is Jill earning 1/3 the amount of as much as Robin? Yes, because 1/3 is saying that Robin earns 3 times more than Jill, and Jill earns 1/3 as much as Robin. Because remember, a fraction is like dividing. That part might confuse some of you. If you need help on this, let me know. All right. So Sam and Eric recorded the total number of miles they walk in 1 week. Sam walks 2 miles each day. Eric walks 4 miles each day. What ordered pair represents the number of miles each has walked in all after 7 days? Well, we remember that we can fill out our chart if we need to, and we can add 2, add 2, add 2, or we can just say that Sam walks 2 times 7, which is 14. So let's make Sam be the X. So it's 14, that's a hug, by the way, comma. Eric walks 4. So after 7 days, we're going to do 4 times 7, which is 28. So if Sam is X and Eric is Y, then our ordered pair is 14, 28. What relationship do you notice between the total number of miles Sam and Eric have each to walk? walked. So our first data point was 2, 4, and another one is 14, 28. So, but I'm going to look at 2, 4 because those are the easiest numbers and the easiest to see for me. So it looks like Eric always walks 2 times more than Sam does because 2 times 2 is 4. Now let me check my times 2 rule with a bigger ordered pair. Is 14 times 2, 28? Yes. So the relationship is that, I'm going to text this. Oh, it all disappears. I hate that. Sorry, guys. So the relationship is that Eric always walks 2 times more than Sam. Voila. All right, that should be all you need to help you with today's classwork, but let me know if you need any other help. I am here for you.